I've received a problem from Bradley. I don't know his last name. I'm assuming it's a he. I don't know where he lives, but the problem he gave is interesting, and I don't think I've covered this before, so I think it's worth covering. So the problem he gave, if I read his note properly, is this. 3 sine squared of x is equal to 1 plus cosine of x. So at first cut, this seems like a difficult problem. You can't solve for x. You would have arc sines and the square roots and cosines, etc., etc. So the way I approach this is anytime that, if I see a cosine x here, but then I see a sine squared x here, I start thinking of what trig identities are at my disposal. And what trig identities involve a sine squared x? Well, the most basic trig identity, and this comes out of the unit circle definition of trig functions, is that sine squared x plus cosine squared x is equal to 1. And that comes out of the fact that the equation of a circle is x squared plus y squared is equal to the radius squared, but if it's a unit circle, is equal to 1 squared. But anyway, hopefully you have this memorized if you've already been watching the trig videos. So what does sine squared x equal? Well, let's solve for it. So sine squared x is equal to 1 minus cosine squared x, right? So we could substitute this term right here with this. And what does that get us? Well, we're just playing around at this point, but at least at that way, everything is in terms of cosine of x. So let's do that. Let's substitute. So we get 3 times sine squared of x. We just showed that sine squared of x is the same thing as 1 minus cosine squared of x. 1 minus cosine squared of x is equal to 1 plus cosine of x. We can simplify it a little bit. 3 minus 3 cosine squared of x is equal to 1 plus cosine of x. I don't know, just for kicks, let's put everything onto the right side of the equation. And you'll see it wasn't just for kicks. 0, right, is equal to, let's put this onto the right side, 3 cosine squared x. And then, see, we have to subtract 3 from this side. Well, let's just write the cosine x first. Plus cosine x. And then 1 minus 3 is minus 2. All right, let me make sure I didn't make a careless mistake. We had negative 3 here. We added 3 cosine squared x to both sides, right? We subtracted 3 from both sides, minus 2, and then this cosine x is this cosine x. Now, what can we do? Well, this is where it gets interesting. Because this looks an awful lot like a quadratic equation, except for the fact that instead of having, ax squared plus bx plus c, we have a cosine squared x. So instead of just having an x squared, we have a whole cosine of x squared. So what do I mean by that? Let me make a substitution, and then I think it'll all become clear to you. Let's make the substitution that a, and I'm just picking the letter a arbitrarily, is equal to cosine of x. So if we were to take the cosine x's in this and replace it with a, what do we get? And I'm just going to switch it around, so I'm going to put the 0 on that side, equals 0. So we get 3, well, cosine squared x, that's the same thing as cosine of x squared, right? So we get 3a squared plus a minus 2 is equal to 0. Well, now we have a pure quadratic, and we can solve it using the quadratic equation. So what's the quadratic equation? Let me write it up here. Negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So what are the roots of this equation? Well, what's minus, and remember this a is different than this a. Maybe I shouldn't have used an a as a letter. But these a, b, and c in the quadratic equations represent the coefficients. So this is a, b is 1, and c is this minus 2. So what are the roots of this? So the a's that solve this, a can equal, and I know I confused you. Let me write it different. Let's make this, instead of a is equal to cosine x, let me say that, I don't know, let me pick a good letter that's not involved in let me say d. So 3d squared plus d minus 2. So now the a, b's, and c's, are definitely the coefficients. So the solutions to this are d, because I didn't want to use a, b, or c. D is equal to minus b, well, b is 1, minus 1, And if this is completely foreign to you, you should review the videos on the quadratic equation. Minus b squared, well that's 1 squared, minus 4ac. So minus 4 times a times 3 times c. Well, c is minus 2, right? So we get that minus cancels there, and we have a 2 there. All of that over 2 times a. A is 3, so we have it over 6. So this equals minus 1 plus or minus the square root. What is this? 4 times 3 times 2, 24, plus 1, 25. Oh, this works out cleanly. Over 6. So that equals minus 1 plus or minus 5 over 6. And so what are the roots? The roots are, what's minus 1 minus 5? That's minus 6 over 6. So it's minus 1. What's the other one? Minus 1 plus 5 is 4. 4 over 6 is 2/3. So the solution to this equation, let me clear up some space. Hopefully, let me clear up some space here. Let me see, what was I doing? Oh, maybe I want to leave. I can get rid of this. You know the identity. And you also know the quadratic formula. And let's see, actually let me get rid of this too. Clear up a bunch of space. I wanted to leave this here because this showed how this turned into a quadratic, but instead of having it in terms of just a variable, we have it in terms of cosine of x, and then we made the substitution d is equal to cosine of x. Anyway, so the solution to this equation is that quadratic is d is equal to minus 1 or 2/3, right? But of course, we made the substitution long ago that d is equal to cosine of x. So the solution to this equation in terms of x is the solution to this equation. Cosine of x is equal to minus 1, or cosine of x is equal to 2/3. Well, this one's easy, right? X is equal to arc cosine of minus 1. I always forget if there's two c's when you do arc cosine. Anyway, so at what degree or radian value does the cosine of x is equal to minus 1? Well, it's at pi, right? So x could equal pi, which is also, or 180 degrees. This one is not as easy. I think I will have to use a calculator for this, unless I'm, whoops. So you may not realize it, but Google is actually a calculator, and a far more advanced calculator than most. So we could use Google to figure out the arc cosine of 2/3. Let's do that. Arc cosine, I don't know if I'm spelling it right, of 2 over 3. Google tells us that it's 0.841 and a bunch of numbers. So x is equal to arc cosine of 2 over 3. So x is equal to 0.84106. Let's see if they work. Just for fun, let's just see if this one works. Let's see if when we substitute pi into this equation, we get the correct answer. Well, what's sine of pi? Let me erase all of this just so we can check it. I'm only going to check pi, the 0.84, and I don't know, that's messy, but you can do that in your own time. So let's check pi. X equals, no, that's not what I wanted to do. So let's make sure this works with the pi. 3 sine squared of pi is equal to 1 plus cosine of pi. Well, what's sine of pi? This is equal to 3 sine of pi squared is equal to 1 plus cosine of pi. Well, sine of pi is 0, right? The y value when you go 180 degrees is 0, so this is 0. And what's cosine of pi? Cosine of pi is negative 1, so 1 plus minus 1. Well, this is true. So pi worked in that equation. I think if you substitute that 0.841068, whatever, you would also find that that works. So thanks, Bradley, for sending this. I thought this was a neat problem because it looks like it's trigonometry, and it was trigonometry, but you have to know a little bit of identities, and then you have to recognize it as a quadratic equation. I will see you in a future video.